Hi, I'm Rusty Steele, Product Marketing Manager for GE Busway Products. I'd like to show you an exciting new product, GE's newly redesigned drip-proof, splash-proof, and outdoor busway, and provide you, the installer, with helpful instructions for installing this new product. As GE's design team developed this product, they utilized a Design for Six Sigma or DFSS process to identify the most important critical to quality items, or CTQs, as defined by our customers. Once identified, the design team set out to deliver a new product that meets the DFSS quality goal of fewer than 3.4 defects per 1 million opportunities. Let's begin by inspecting a sample of the new product. Our customers identified ease of installation and reliability as the two most important CTQs for outdoor busway. We address these CTQs with the design of this innovative new joint shield. As you can see, this joint shield will bridge the joint on the top and the bottom. And to install the new joint shield, you simply center the shield across the joint length, align the edges of the joint shield with the housing ground side plates, and then using the captive spring clips provided, simply snap into the detents on the busway housing. As you can see, this entire action takes only a few seconds. And this shield replaces the joint cover on the old design, which was held in place by up to 20 bolts and could take up to 20 minutes to install per joint. Also, this new shield helps reduce the possibility for errors during installation because the bottom shield is identical to the top shield, making it impossible for an installation crew to put the wrong shield on top. Also, unlike the old design, which required RTV sealant to be applied along the gaskets on the covers, these new shields are equipped with an EPDM gasket, which forms a watertight seal against the housing side plate without the use of RTV. Some other changes that you'll notice with the new design include the new weather shield insulator in the joint pack. This insulator is distinguished from the insulator used on standard indoor bus by its pale green color. It's made from a high-pressure laminate epoxy glass, and this material was selected following an intensive DFSS testing process. Our testing program included water absorption, thermal aging, wet and dry arc track, as well as corona discharge and mega-ohm testing of water-soaked samples. The Weather Shield insulator exhibited superior performance in all of these severe duty tests, and we're confident that no better busway joint insulator material is available in the industry. Another noticeable change is the removal of the external steel coat sealant that was present on the old design along the housing seams. In place of this sealant, we now use an integral gasket material. This gasket material is put into place in these grooves in the housing during the assembly process, both on the top and the bottom. Then during assembly, as the housing is snapped together, these gaskets form a watertight seal, and we're assured of 100% coverage along the seam. As you can see, we have made significant improvements to the design, and we are confident that you will agree that this product is much easier to install and more user-friendly than any other outdoor bus available. In order to demonstrate this, we will now go to an actual job site and watch as the installation crew installs a run of the new outdoor bus. Here you see an overview of the job site. Upon closer examination, we see the flat-wise elbow which begins our run. This elbow has been wrapped with protective plastic. Also, we see that the installer has done a good job of preparing the site by locating and installing all necessary supports, including drop rods and clevis-type busway hangers. Proper care of the busway prior to installation is essential. The busway should always be stored indoors in a clean, dry area and protected from common pitfalls on the job site. These hazards include mechanical damage, corrosive fumes or liquids, and salts or wet concrete. Begin by moving the bus as close as possible to the installation point before removing from the crate. This will help protect the busway from damage prior to installation. Next, remove the wood crating and protective plastic wrap from the bus. At this point, check carefully for any damage that may have occurred during shipment. On all fittings, check to ensure that the plastic corner sealing caps are in good condition. And on all pieces, visually inspect the integral gasketing near the housing spacers to ensure that it has not been gouged, punctured, or otherwise damaged during shipment. Inside each crate of Busway is a copy of installation instructions, GEH 40087. Take some time to read these instructions thoroughly before proceeding. Also included with each shipment is an as-built equipment drawing for the complete run. Note in particular that each piece is numbered on the drawing and that this number corresponds to the label on each piece. Use this information to help pre-plan the installation sequence. Before installing the first piece, remove and discard the 2 unpainted shipping protectors, but retain the bolts for later mounting of the joint caps. Each piece of bus should be individually mega-ohm tested prior to installation to verify insulation integrity. Be sure to check resistance between each phase and ground. The resistance values should be infinity. Next, move the first piece of bus into position. Notice in our example, we only remove the protective wrapping from the exposed elbow immediately prior to installation. Before proceeding, we perform a measure check on the elbow. Now we are ready to connect the first piece. To do this, loosen the joint bolt slightly and slide the sections together. Note, be sure that the bus bars interleave with the insulators and that the housing ground side plates slide between the outside insulators and the joint sides. Secure the hangers or support devices. Next, use the joint cap as a gauge by reversing the cap so that the gasket side faces out. Line up the bolt holes in the cap with the holes in the housing spacers and tighten the bolts with your fingers. By doing this, you can set the correct dimension across the joint. This will ensure that the joint shields fit correctly. Once the dimension is set, tighten the joint through bolt to 50 foot-pounds. Proper level and alignment of the bus is essential. Check often to ensure that the run is level. If adjustments are necessary, these should be made by raising or lowering the bus supports. Once proper alignment and level is obtained, remove the joint caps from the gauge position and install the top and bottom joint shields. These shields are equipped with gasket strips to form a watertight seal against the joint sides. Set the shields in place, bridging the joint. Align the edges of the shields with the edges of the housing ground plates and fasten the shields by pressing the wire-formed springs into the spring detents. Note the top and bottom shields are identical and are equipped with neoprene weep hole plugs. For UL outdoor applications, remove only the bottom weep hole plugs. For IEC 529 degrees of protection, including IP54, IP65, or IP66, do not remove the plug. Continue by installing the top joint shield in the same manner. Note, the weep hole plug should never be removed from the top shield. Next, install the joint caps in the final position with the gaskets facing inward. Tighten the joint cap bolts to 25 foot-pounds. In our example, the bottom plug is removed to comply with UL outdoor rating. Continue to add additional pieces to the run, following the steps used to install the first piece. We continue by identifying the next three pieces in the run, matching the numbers on the drawing with the item labels. In our example, we will pre-assemble these three pieces prior to attaching to the run. We do this by following the same steps outlined previously. We slide the adjacent pieces together. First, the transposition length into the short straight length. We align the joint assembly with housing ground side plates and attach the joint caps in reverse position to set joint length. Torque joint bolt to 50 foot-pounds. Remove the joint caps and install joint shields on the top and bottom. Reinstall joint caps in the final position and torque bolts to 25 foot-pounds. Before installing the elbow to the opposite end of the transposition length, check again to verify proper phase orientation. Slide the elbow joint into place and assemble the joint as before. Once the subassembly is complete, perform a measure check before proceeding. Lift the completed subassembly into position and slide the joint into place with the previous piece. Attach the supporting hangers and continue with joint alignment, torquing of joint bolts, and assembly of joint shields and caps as before. Once complete, check again for level. Then pull a horizontal string along the run to verify proper lateral alignment. If adjustments to level or alignment are necessary, be sure to remove joint caps and shields before realigning. Perform a measure check on the completed portion of the run. Next, slide the adjacent vertical piece into position. Adjust alignment of joint. Attach the joint caps in reverse position and torque the joint bolt. Remove caps and install the joint shields. Reattach joint caps in the final position and tighten. The final piece in this run is an end-cable tap box. Move the tap box into position and slide the joint into place. Attach joint caps in reverse position to set correct joint dimension. Be sure to support the tap box adequately by connecting supports to both corner brackets on the tap box. Check for level and tighten all bolted connections. As before, remove the bottom weep hole plug. Note that this joint is equipped with GE's exclusive joint guard protection, which enables the installer to visually verify correct bolt tension when the plug is removed. Let's take a closer look at this time-saving feature. To demonstrate the function of the bolt, We begin with the loose joint bolt. Note that the color indicator in the head of the bolt is red. As the installer begins to tighten the bolt and place the bolt under increased tension, the indicator gradually changes color. Once the bolt is torqued to 50 foot-pounds and the correct tension is achieved, the indicator is completely black. The installer can now reinstall the weep pole plug if so desired. Resuming our installation, we now remove the bottom drain plug on the edgewise elbow, which is in the up position. Note, never remove an elbow drain plug facing upwards. Now that the installation is almost complete, let's review a couple of additional installation tips. First, let's observe the proper technique for removing joint cap knockouts. These knockouts should be removed only if an adjustment is needed in the joint nominal position. By removing the appropriate knockouts, the installer can adjust each joint by plus or minus 1/2 inch in length. Next, let's observe the proper technique for replacing a joint cap gasket. These gaskets should be replaced with new ones whenever a cap is removed for service. First, peel off the old gasket and discard. Then remove the adhesive strip coverings from the rear of the new gasket and press into place. Spare gaskets are provided with each shipment of bus. After performing a final measure check on the completed run, the installation is now complete. By following the procedures and tips presented in this video, along with the printed installation instructions, we are confident that you will enjoy a finished product providing years of reliable service.